divided into different management units. So each one of these white polygons kind of tells us what portion of the prairie we're talking about and what types of treatments we estimate are in order to try to have success to remove the invasive species and to bring back those historic native plants that we're trying to encourage. Okay, so let's go back to the grazing animals for a minute. Let's go back to the bison. Let's go back to the fact that they like to eat ice cream plants. Let's go back to the fact that once the bison disappears, we put cows in pasture. And let's go back to the fact that those cows every day ate those ice cream plants and they disappeared. Well, interestingly, if we could go back in time, we could all jump on board my time-traveling helicopter. We could go back to the prairie, maybe a hot tub. Now, we couldn't fly over the hot tub. Our time-traveling helicopter, that was a pretty good movie. We're in our time-traveling helicopter. It's going back in time. We're in the year 1500. We're flying over the Pasadena prairies and we're looking straight down. Well, it turns out that when we look down, the prairie would have been covered in about 80% of its coverage with only about 5 species of grass. It turns out we call those grasses that dominate the coverage of the surface of the land a dominant species. That's why, because they dominate the coverage. And those grasses would have been eastern gamagrass, big bluestem, switchgrass, Indian grass, a very short list of dominant grasses that have covered the prairie. Here's the interesting thing. It turns out that those dominant grasses are also the ice cream plants. So I'm interchanging two terms for the same short list of plants here. So the prairies were composed in large extent by a very short list of these dominant grasses, and when we fenced our pastures in, the cows ate them all up and they disappeared. So part of our bringing back the natives, part of our restoration project includes growing these locally rare grasses and wildflowers in the Nature Center's greenhouse and native plant nursery, and then putting them back in the prairie. And that's sometimes a hard to understand question. Students come to do a project like this, they walk out into the prairie, they see there's grass everywhere, and they say, why are we planting grass in the prairie where there's already grass? Well, this is the reason. It turns out that those ice cream plants, dominant grasses, were the tall grasses, sweet grasses that disappeared due to our overgrazing practices over the last several centuries in North America. So we grow the plants, and then we look for help to try to get them put back in the prairie. We grow about 20,000 of those 1-gallon containers of those locally rare grasses and wildflowers, and then through service learning projects, students come back and help us plant them in the field. The service part of it is pretty obvious. You can see it here as we go out. We dig a hole, we give them a drink of water, and the learning part of it is this moment in time that we're having right now. It's been a very successful effort for us. You heard me mention 20,000 containers a year. That's bringing significant change to the landscape. Anybody go to Deer Park High School? Yep. These are Deer Park High School students. That was in 2005, probably a little before your time at Deer Park High School. But directly across the entrance, the main entrance to Deer Park High School, is kind of a little small strip center that's got a doctor's dentist's office in it, and there, at least at this point, was an open field that had one of those remaining wetland depressional features that I talked so much about. And in that wetland was one of the largest, most beautiful, fragrant prairie wildflowers that we have, called spider lilies. So the entirety of 9th grade, for 2 days in a row, walked right across from their entrance, and they dug these spider lilies up before the bulldozers came and built whatever structure is there now. Those spider lilies today are blooming in the prairie along the entrance to the Nature Center. So the concept here is one of a living museum. We're trying to collect the best pieces of what our local ecology once contained and bring it to an area that will have long-term preservation. There's a pretty good chance that this place may be the only remnant that your children will ever have to see what Harris County once looked like. It's the best piece of wild land remaining in all of Harris County. And it's getting better because of projects such as this. We go into the field, we take those locally rare grasses and wildflowers out. These are students from Pasadena High School. I don't know if any of you had Miss Swick for Danville, Pasadena students. So we take a big jug of water, we dig a hole, we give the plants a drink of water. If it's dry, we probably would not need to do what these girls are doing today, because it is really wet out here. We also, once a year, have a big family event called Prairie Pandemonium. This is the entire community that can come and help with this. We typically have about 100 participants, and generally, before noon, we plant about 3,000 of those 1-gallon containers. So that's a lot of activity. It creates a lot of pandemonium, which is why it's called Prairie Pandemonium. It's another great way for us to restore prairies. We're going to wait and show our movie if we have time at the end here. So here's what we did in 2013. I show this picture because I want you to understand the project is bringing large-scale, meaningful change to the Nature Center. That's a big area of land, and those are a large number of plants. You can see all the various schools that assisted in that effort in 2013. We also manage prairies by trying to mimic the effects that bison once had, but I'll admit that I'm not a cowboy, and I will also admit that even cowboys can't manage bison. They are wild animals that are very difficult, and as a result, we have begun to use tractor mowing, which mimics, remember, that high-intensity grazing effect? So this somewhat replicates that. We lose a lot of the effects that the bison might have had. Yes?
Did you actually hit bison?
We have bison now, and the bison that we have are in a little 7-acre pasture. And in order to use bison as a management tool is when it really gets difficult. They're difficult enough just in a small pasture, but in order to use grazing animals as a restoration tool, remember that map that showed all the white management units? Those used to be grazing cells where we had cattle in it. So in order to get the high-intensity, low-frequency grazing effect, you have to put a whole bunch of grazing animals in one unit, and you have to move them to the next unit so that the grazing unit can rest. So you have to move this one herd all the way around the place to get good success with your grazing effort. And bison do what they want to do, when they want to do it. And they're big enough to let you know that. We had a truck in the center that's got a couple of great big dents in bison charging the truck. So that gives you a little bit of indication. Well, bison also are prone to a phenomenon known as rage syndrome. And you can make them mad, and when they get mad, it is like a raging bull kind of thing. So they're a very difficult management tool. George, on the mower, he's a lot easier management tool to manage than the bison are. We also use the chainsaw. We have isolated trees. One of the interesting things about the resilience of the Chinese tallow, just cutting it down at ground level does not kill the tree. If you don't apply a cut stump herbicide to it, tallow trees resprout with multiple trunks. So it's a very difficult tree to kill. Probably one of the most misunderstood elements of prairie ecology is fire. Today, land managers use a type of fire called prescribed burning. It's different than those big wildfires. It's not like you just throw a match in the field and see what happens. A prescribed burn actually has 3 elements to it. The first of which is, you know where the fire is going to begin and end. We have a burn unit. And in this image, the burn unit is contained by a mowed fire break where we remove the grass and it's very short. It has a natural fire break, bayou, or we'll call that Armand Bayou. But in any case, a prescribed burn always begins and ends in a predetermined burn unit. The second part of a prescribed burn is that it's only done under very specific weather conditions. Imagine the wind's blowing 50 miles an hour. It'd be real hard to stop a fire when the flames are being fanned by that type of wind. Another good example is that we have to have a very consistent wind direction. You don't want the wind changing directions. Wouldn't want it coming out of the south and then have a cool front come and have it switch out of the north. That makes the fire travel in very unpredictable directions if the wind changes. The third and last element of a prescribed burn is that it is always to achieve a specific goal, ecological goal or objective. We want the fire to do something that benefits our restoration plan. Typically, these fires are conducted to try to suppress the growth of woody trees and shrubs. We want the fire to kill tallow trees and other invasive trees and shrubs. We're limited to burning about 25 acres at a time. We use this canister called a drip torch that has that long nozzle. It kind of drips out a mixture of gasoline and diesel and then ignites the fire that travels into the burn unit. You can see the flames passing underneath the trees behind. That's a hot fire, maybe 1,000, 1,200 degrees at 10 or 12 feet above the land surface. And as that heat travels under trees, that intense heat is focused on the tree trunks, the tree limbs, and on that very sensitive growth tissue, the meristematic tissue. So this is why fires are important in grasslands. They kill and suppress the growth of trees and shrubs. So think back to the picture where the closed canopy tallow forest had outcompeted the grasses. All of that diverse plant community had disappeared. This is why prairies are fire dependent. When grass is burned, that grass fuel generates heat, which kills the trees and shrubs, which otherwise will colonize and dominate and replace the prairie plants. Now, if you're a prairie plant that's been out there for a number of years, one of two things has happened. You've either burned up and flashed off into the environment, and in fact, the winter prairie grasses do burn away. That dead, dormant thatch oftentimes volatilizes into the atmosphere. If you're a living plant, however, a tree or shrub, that above ground portion of you has also died. Perhaps the whole tree all the way through the roots has died also. If you're a little blue stem grass such as this, though, you've got your own set of adapted strategies that have let you live through that hot fire. This tender growth tissue is located right at the soil surface, maybe even a little below it. So that hot 1,000 degrees is way up above where the bulk of your body is at. That's one important strategy, is where the living tissue is located. The other is that most of that tissue is now surrounded by wet prairie soil, which is excellent insulator. So as that fire passes across the prairie, there's a very negligible change in the temperature, even just an inch below the soil surface, no change in temperature. So grasses are a very well adapted plant to endure that type of intense heat that the prairie fire generates. Trees and shrubs do not. Another important element of the fire is that in the wintertime, the prairie surface is now blackened. And in January, February, that winter sun is shining down on this black prairie soil surface, and the soils begin to warm. And that warming soil begins to promote a real bloom in the bacteria population. And you think, well, what does it matter if bacteria are living in the soil? Well, it turns out these bacteria do a very important thing. If you've ever looked at a fertilizer bag at the hardware store, fertilize the lawn, there are 3 numbers on the front of that fertilizer bag. And they indicate the ratio of nitrogen, phosphorus, and potassium. And nitrogen particularly is a very important element for plant growth. It's called a growth limiting factor. If you don't have enough nitrogen, plants don't grow well. If you have it in abundance, they grow prolifically. Well, these bacteria that begin to bloom after the fire has passed have the ability to pull nitrogen out of the atmosphere and pull it down into the soil and fix it in the soil where plants can then use it. They're called nitrogen-fixing bacteria. And because of that, they enrich the soil's nutrients, and the prairie really blooms after the fire has passed and the nitrogen has been fixed in the soil where the plants can access it. So as those plants are growing vigorously, it not only helps the plant community, but when the plant community is flourishing, so is the wildlife. One of the reasons that native peoples began to increase fire frequency, burning the prairies more often, was to attract these game animals into this very desirable grazing habitat for the animals that would come to it. It's quite a spectacle of nature, and you can see it from this parking lot when we're burning. These big smoke plumes rise 10,000 feet up into the air, and if you're fortunate enough to be part of the burn team, we use mostly volunteers to help us with this. Being that close to a big 25-acre roaring prairie fire is quite a spectacle that we'll never forget. Nature Center has one of the longest burn histories in Texas. We began burning in 1979. One of the things you notice about these bar graphs is, remember when we started opening prairies up? We were killing tallows. We're actually creating more prairie acreage, and that means every year we create more work for Mark Kramer when we're doing that. So every year we have to burn more, we have to mow more, and we become more successful at reclaiming those tallow forests and restoring them to prairie habitats. That means more work as we go along. Let's see if we have time to look at those at the end here. Another important element of what we do is we monitor the prairie. We have 32 different study areas in the prairie where we go out every spring and every fall, and we walk between these two fixed points in the prairie, two metal posts. We take a square piece of PVC pipe and we drop it down onto the ground, and we look for how the plant community is changing. This vegetation transect data gathering enables me to scientifically determine, are more tallows growing out there? You know, we can create that same bar graph of any one of these species, and that helps me assess, is what we're doing to restore the prairie actually working? And if this data collection determines that, in fact, in spite of everything we're doing, there's more and more tallows growing in that unit, then what we're doing is not working. We need to adapt and change. Do something that's going to help us achieve our goals. By contrast, if it's mainly gamma grass, switchgrass, those dominant grasses we're trying to grow increasing, that tells us that we are moving in the right direction. So the collection of that data helps us determine how our efforts are progressing. This is a picture of Armand Bayou Prairie in springtime. Notice three distinct images in that prairie. One of them's black, one of them's green, one of them's brown. Well, what we see here is the creation of a habitat mosaic. Really what you're looking at is what would have been played out on the upper Texas coast underneath our time-traveling helicopter in the year 1500, but played out on a huge scale. Remember, the fires would have burned for great distances. The Harris County-sized herd would have covered great areas of grass and left it the way this mowing units were. And the area in the center left untouched. Well, we create this habitat mosaic at the Nature Center so that we can support a great diversity of wildlife. In North America, wildlife would have flocked to each one of these different areas, just depending on how they were adapted. And wildlife has unique adaptations to help it make a living. I'll give you an example. The American snipe, one of the birds that migrates the longest distance of any bird in the world, comes to the Texas coast in the wintertime to escape that harsh winter climate. And they really love to feed in these burned prairie units. All the vegetation has been burned away. They've got a long bill that enables them to probe down into those soft winter soils looking for invertebrates, looking for worms, looking for other things that make their diet up. If you were a grazing animal, like a deer or a rabbit, you'd look for this new green growth that you see in the bottom right corner. If you're a migrating songbird,